afternoon, everyone. This is the pre-launch news conference for OSIRIS-REx, scheduled to be launched on Thursday at 7:05 p.m. aboard a United Launch Alliance Atlas V rocket. And here to discuss the upcoming mission, the countdown, the launch, and the spacecraft, we have joining us Jeffrey Yoder, the Acting Associate Administrator from the NASA Science Mission Directorate in Washington. Dante Loretta, the Principal Investigator from the University of Arizona at Tucson. Tim Dunn, the NASA Launch Director from the Launch Services Program at the Kennedy Space Center. Scott Messer, the Program Manager for NASA Missions from the United Launch Alliance in Centennial, Colorado. Michael Donnelly, the NASA OSIRIS-REx Project Manager from NASA's Goddard Space Flight Center in Greenbelt, Maryland. Rich Coons, the OSIRIS-REx Program Manager from Lockheed Martin Space Systems in Denver. And Clay Flynn, the Launch Weather Officer from the 45th Weather Squadron from Cape Canaveral Air Force Station. And we'll begin first with Jeff Yoder. Jeff?
Thank you. Well, good afternoon. It's my pleasure to welcome you to the launch of NASA's first mission to go out, touch a near-Earth asteroid Bennu, and bring a sample back to us. Well, the NASA Science Mission Directorate, its mission is to innovate, explore, discover, and inspire. With over 100 missions, our diverse portfolio gives us the opportunity to accomplish that mission in many ways, not just to the scientific community, but to the world at large. In fact, NASA science is interconnected. With our astrophysics, earth science, heliophysics, and of course planetary science will be part of this unique mission that you'll hear about more today. 1 year ago, the New Horizons mission wowed us as it flew by Pluto. Last July, our Juno mission entered the Jupiter's orbit and is now bringing back amazing photos, and will continue over the next year and a half to produce amazing, great science. Well, NASA science is the greatest engine of scientific discovery in the planet today, and you will hear more about one of the engine's vital mechanisms. So, George?
Thank you, Jeff. Now to Dante Loretta, who's the Principal Investigator for OSIRIS-REx from the University of Arizona. Dante?
Thank you, George, and thanks everybody for being here. This is a great milestone for this team. For many of us, including myself, it's something that's been over a decade in the works. I'm going to tell you about our science objectives today and what we're going to achieve with this amazing mission to asteroid Bennu and back. If I could have my video, please. The mission name is an awesome acronym that describes our primary science objectives. And as I like to say, it's also my fault, so here we go. The first letter in the acronym is the O. This is for our origins investigation. And this really is what drives our program. We're going to asteroid Bennu because it's a time capsule from the earliest stages of solar system formation, back when our planetary system was spread across as dust grains in a swirling cloud around our growing protostar. Inside this region of the protoplanetary disk, there were bodies that were accumulating. Many of them were getting water ice and organic material, key compounds that we believe may have led to the habitability of our planet and even to the origin of life on Earth. These are really critical because our Earth went through a major period of geologic upheaval during the late heavy bombardment, where millions of asteroids collided with the surface, sterilizing our planet. We're following on the heels of successful NASA missions like Stardust. And in fact, as you'll hear, our return capsule is using the same technology that the Stardust mission did to bring those amazing materials back. And sample return is really at the forefront of planetary exploration. Not only are we going to get this material into our laboratories for precise chemical analyses that can't be duplicated by spacecraft instruments, but this is going to be a treasure trove of information and material for scientists yet to come. We're talking about analyzing compounds that are present in these materials, in some cases at the parts per million level. We have to get these samples into our laboratories to investigate these driving questions for OSIRIS-REx. And I'm very excited to be able to lead this mission. The next part of our acronym is the spectral interpretation. And we've had the benefit of studying our target asteroid Bennu using some of the best telescopes on Earth and in space, including the Hubble Space Telescope, the Spitzer Space Telescope, telescopes in Tucson, Hawaii, Chile, Canary Islands, all over our planet. And we have a pretty good data set, and we think we know a lot about what this asteroid is made out of. But we're also bringing fantastic science instruments with us, like the OSIRIS visible and infrared spectrometer from the Goddard Space Flight Center, and the OTES thermal emission spectrometer from our partners at Arizona State University. And we're going to use these instruments along with our camera systems from Arizona, University of Arizona, and our laser altimeter from the Canadian Space Agency to ground truth that information and ultimately map the surface of the asteroid for the key organic compounds so that we can pick the best spot on the surface of the asteroid to get those samples. And that leads into our next investigation, which we call the resource identification. When I first came up with that term, I thought I was thinking really futuristic sci-fi, that we're going to go out to asteroids and use these materials to further space exploration. And now we see that that may be happening in the near future. We're going to pioneer the technologies and the capabilities that to send a spacecraft out to asteroid Bennu and perform detailed global mapping of the entire surface to understand its composition and its mineralogy, ultimately focusing in on regions of interest where we're going to get super high resolution shots of the surface to understand that material. The next part of our investigation is about the security aspect. By virtue of our mission design, we're going to an asteroid with an orbit very similar to Earth. We want to know what its trajectory is going to be in the future in case it represents a potential hazard. We're going to study a phenomenon known as the Yarkovsky effect, which is essentially the absorption of energy from sun, emission of that energy back out as heat, and that causes a small thrust on the asteroid, changing its trajectory over time. Since we've been monitoring asteroid Bennu beginning in 1999, we've seen it change its position due to the Yarkovsky effect alone by over 160 kilometers. So we really want to understand this phenomena so that we can better understand asteroid Bennu and apply that understanding to all asteroids, not only in near-Earth space, but throughout our solar system. And then finally, we are a regolith explorer. Regolith is what we call the loose blanket of gravel and dust on the surface of these airless bodies. And the ultimate objective is to bring those back into our labs for analysis. But we also want to understand how that material behaves in a microgravity environment. You got to remember, Bennu is only 500 meters across, like the size of a small mountain in outer space. And we don't really understand granular mechanics in that kind of microgravity environment. So by the act of putting our TAG-SAM device onto the surface of the asteroid to collect the sample, in and of itself, we're performing a fantastic science experiment. So we've got great science ahead of us. I'm really excited to get to this milestone, to get OSIRIS-REx launched on its journey to Bennu and back. Back to George.
Thank you, Durante. Now to Tim Dunn, the NASA Launch Director from the Kennedy Space Center Launch Services Program. Tim, talk to us about the countdown.
Thank you, George. I'm proud to be here today representing the women and men of NASA's Launch Services Program, and I'm thrilled to be the launch director for OSIRIS-REx. This exotic and highly complex cutting-edge science mission brings added excitement to our entire launch team. Working alongside our United Launch Alliance colleagues, the engineers and analysts of NASA LSP take great pride in launching OSIRIS-REx. NASA has a terrific record flying on the Atlas V. We've successfully launched 12 missions on this rocket. Missions to Pluto, Jupiter, the Moon, the Sun, the radiation belts, 3 spacecraft to Mars, and now the asteroid Bennu. OSIRIS-REx will be the 13th NASA mission on Atlas V and the 65th Atlas V launch overall. OSIRIS-REx will launch on an Atlas V 411 from Space Launch Complex 41. Slick 41 is proud to have hosted 53 Atlas V launches to date. Now I'd like to show a video of the ULA crew receiving and assembling the Atlas V launch vehicle and mating the OSIRIS-REx spacecraft at Complex 41. Here you see in July we received the second stage, the Centaur, from Decatur, Alabama. It came by way of trailer. The first stage came next, and it came on the Mariner ship. These Atlas V stages are manufactured in ULA's state-of-the-art factory in Decatur, Alabama. They're transported to Cape Canaveral via the ship and sometimes over the road as required. The offload of the first stage took it to the ASOC where it underwent processing there, and then out to the pad earlier in August. Here you see the stacked Centaur, the second stage, in an off-site vertical integration configuration with the boat tail and the interstage assembly, and it's being raised and mated to the top of the first stage Atlas V booster. The 411 configuration of Atlas V has one solid rocket motor, and here you see a sequence of that Aerojet Rocketdyne solid rocket booster being mated at the VIF to the north side of the Atlas V. And on the early morning hours of the 29th of August, we rolled out this beauty, the encapsulated assembly with OSIRIS-REx inside the payload fairing. We found a little moment in time where the weather cooperated and we were able to successfully lift in the midst of a lot of bad weather. As you can see here, the storm clouds were brewing that day, but we had a very smooth day and were able to successfully mate that encapsulated assembly at the top of the launch vehicle. The OSIRIS-REx launch campaign has gone very well. Over the past 8 days since OSIRIS-REx spacecraft mate, the Atlas V team has been busy with launch preparations. Last Wednesday, we performed the final integrated systems test with the spacecraft and rocket. Then last Thursday, the combined NASA and ULA launch team held the flight readiness review where we assessed all processing and pre-launch preparations for this mission. Last Friday, we performed a successful mission dress rehearsal to exercise and prepare the entire ULA, NASA, Lockheed Martin, and Air Force Atlas V launch team. Just this morning, we conducted the launch readiness review for the OSIRIS-REx mission. Senior managers from NASA KSC, Goddard Space Flight Center, and headquarters, as well as ULA and the Air Force, assessed the readiness of the rocket, the spacecraft, and range assets to proceed with launch on Thursday evening. Tomorrow, we will begin our final launch preparations at approximately 9 a.m. Eastern Time by rolling the Atlas V on its mobile launch platform approximately 1/4 mile north from the VIF, the vertical integration facility, to the launch pad at Slick 41. On Thursday, the launch crew will begin arriving on console midday. The crew will perform the final preparations of Atlas V power-on and electrical checks beginning at noon Eastern Time. This will be followed just before 5 p.m. by loading the super-cold cryogenic propellants on board. First, liquid oxygen into the tanks of the first stage booster and second stage Centaur, then liquid hydrogen into the second stage. Final flight control tests will be performed along with final tests with Eastern Range instrumentation, and then we will be ready for launch Thursday evening at 7:05 p.m. Eastern Time with a 115-minute launch window. In summary, the Atlas V rocket and range equipment are ready, and the combined government and contractor launch team is prepared to launch this fantastic asteroid sample retrieval mission, OSIRIS-REx. Back to you, George.
Thank you, Tim. And now to Scott Messer, the program manager for NASA missions from the United Launch Alliance. Scott?
Thank you, George. On behalf of United Launch Alliance, I just wanted to note that we are honored to be here on day one of the OSIRIS-REx, or one day before launch of the OSIRIS-REx mission. This is a very exciting mission for us and for me personally, and I get really enthusiastic every time I come down and learn more about this mission. OSIRIS-REx will be the 8th launch for ULA in 2016 and the 111th launch of ULA since its formation in December of 2016. It'll also be the 4th launch of this particular configuration, the 411. The 411 configuration includes a 4-meter payload fairing which houses the spacecraft. It's got a single solid rocket booster, and the first stage is powered by the RD-180 built by RD Amros. And the Centaur upper stage is powered by the Aerojet Rocketdyne RL-10A engine. And now I've got a short animated video that will show the events that we expect to occur at launch and after launch tomorrow.
The following profile details the important events of this mission using approximate times.
6, 5, 4, 3, 2. Atlas engine ignition. 1, 0 and liftoff of the Atlas V rocket carrying the...
The Atlas V RD-180 main engine and a single solid rocket booster ignite to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 57 seconds. At 69 seconds, the vehicle experiences maximum dynamic pressure. The solid rocket booster is jettisoned in less than 2.5 minutes. As it approaches booster engine cutoff, the Atlas V is burning propellant at the rate of 1,672 pounds per second, traveling at over 12,000 miles per hour, and located 62 miles in altitude and 188 miles downrange. Booster engine cutoff occurs about 4 minutes after liftoff. The booster stage is jettisoned 6 seconds later. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned about 8 seconds later. The vehicle now weighs just 6% of what it did at liftoff 4.5 minutes earlier. Cutoff of the Centaur main engine occurs just over 12 minutes after launch. The mission now enters a 21-minute coast phase. At 33 minutes 48 seconds, the Centaur main engine is restarted. This burn will last nearly 6 minutes. Following the second Centaur main engine cutoff at 40 minutes 38 seconds, the mission enters a final 15-minute coast phase. At 55 minutes 37 seconds, Centaur releases NASA's OSIRIS-REx on its way to its rendezvous with the asteroid Bennu.
So as noted in the video, the timelines discussed there are approximate each day. We do have a 2-hour launch window, or as Tim mentioned, 115 minutes each day, and with inside that we've got a launch attempt every 5 minutes. So times can vary depending upon where we launch. The timelines that were presented in the video are for a launch at the middle of the window. So if we launch on Thursday night, when I hope we do, which will be at the start of the window, some of those timelines will be a little bit longer. So for example, spacecraft separation would occur about 3.5 minutes after what was noted in that video. It's just if anybody was writing down times as the video was going along. As I noted, we are proud to deliver the OSIRIS-REx spacecraft to its orbit. We recognize that this is a risky and technically challenging business, and so we'll continue to deliver with our reliable processes, deliver the nation's most important payloads and critical capabilities to orbit. And just once again, thank you to all of our mission partners. The entire ULA team looks forward to a successful launch of OSIRIS-REx on Thursday night. And so with that, I'll do a go Atlas, go Centaur, and go OSIRIS-REx. Back to you, George.
Thank you, Scott. We'll go now to Michael Donnelly, who is the NASA OSIRIS-REx project manager from NASA's Goddard Space Flight Center. Michael?
Okay, so like everybody else, I'm happy to be here. I'm happy to be launching on Thursday. So picking up where the ULA video ended, if you could start the first video for me. 59 minutes, and this is with the opening of the launch window on the very first day. The spacecraft separates from the launch vehicle. About 4 minutes in, the solar rays will deploy after the rates have been damped. There's another, 13 minutes or so while we slew the spacecraft to a favorable communications attitude for Canberra, and we will establish two-way communication. So 17 minutes after separation, we should have stable communications between the spacecraft and Canberra and be able to determine that the spacecraft is safe. 14 days after launch, we will turn on the instruments and check them out, and then we'll turn them back off. About 1 year after launch, after going around the sun once, we'll do an Earth gravity assist and change the orbit plane of the spacecraft, put it in the same plane as the asteroid Bennu. And then just shy of 2 years after launch, we'll actually get to Bennu in August of 2018. Start all of our measurements, all of our observations, and pick a site so that we can safely tag in July of 2020. If we can go to the next video, please. This is the instrument suite that will support all those observations. From the PI's facility, we have the OSIRIS-REx camera suite. That's a suite of 3 visible cameras, the Polycam, MapCam, and SamCam. From Arizona State University, we get one of our 2 spectrometers. That would be the OSIRIS-REx thermal emission spectrometer. And from Goddard Space Flight Center, we get the second spectrometer, the OSIRIS-REx visible and infrared spectrometer, OVIRS. Between those 2 spectrometers, we cover the wavelengths of 0.4 microns out to 50 microns. From our Canadian partners, CSA, and their contractor, McDonald, Detweiler and Associates, we get the OSIRIS-REx laser altimeter, which will be used for mapping the asteroid. And lastly, from a team of students from MIT and Harvard, we get our student collaboration instrument, which is the regolith X-ray imaging spectrometer. And so these 5 instruments make up that suite of instruments that will be used to pick out the sample site, do all that exciting science that Dante mentioned that made up his acronym, and help us bring a sample back in September of 2023, right? Yeah, September 24th, 2023. There's way too many Septembers in this mission. So, all right, George.
All right, thank you, Michael. Now to Rich Coons. He's the OSIRIS-REx Program Manager from Lockheed Martin Space Systems. Rich?
Hi, if we could actually start the first video. So there's one additional payload on the OSIRIS-REx spacecraft, and that's actually the TAG-SAM arm. So the TAG-SAM arm starts with the sample head, and that's what will actually go and collect the sample from Bennu. It's about 12 inches in diameter, and we've been testing it now for several years. That's connected to an arm that's about 10 feet long that contains a pogo assembly so that we can stay in contact with the asteroid for the 3 seconds that it'll take for us to collect our sample. When we sense that contact, the compressed gas will be released, and then we'll actually collect that sample in the head as a function of releasing that gas. We've tested this arm extensively over the last decade to make sure that we can collect more than enough sample in the environment that we expect to see in space. So we've exposed it to vacuum, we've exposed it to temperature, we've tested it both pre and post vibration, and we've tested it over a very wide range of materials. If we can start the next video. Now, how are we actually going to use that head? So the first thing we have to do is we launch with the arm stowed in its configuration. So we'll release the head and then deploy the arm, getting it all the way out. We get to practice doing the tag maneuver as we get closer to collecting the sample, which is shown here. Once we detect the contact, we'll release the gas. When we release that gas, it actually will mobilize the material and collect it in the head. Once we've done the collection, we actually go up and do a spin maneuver where we're able to tell how much material we have to within 20 to 40 grams of material. Once we know we have enough material, we stow the head and close it into the SRC. It is the same SRC that successfully returned the Stardust samples. So it'll return back to Utah in 2023. When it re-enters the environment, it's traveling 27,000 miles an hour, and by the time it gently touches down, it's moving less than 10. And we'll move it from UTTR to Johnson Space Center, where it's a world-class curation facility, and those samples will be evaluated for many years to come. So in order to get to that point, we had to do a lot once we arrived here at Kennedy Space Center. So if we can play the third video. We traveled on a C-17 aircraft. We arrived here on May 20th. Turns out that there was a thunderstorm all day. They were worried about diverting us, It cleared up and it was sunny as we landed. We were able to move it into the high bay the next day, where we took it out of its shipping container and lifted it onto its spin balance table. And the first thing we did is made sure that when we spin the spacecraft, that it was balanced the way that we expected it to be, so that we understood how we would control it when it was here. After that, we had to remove the solar arrays in order to finish the processing. So this is our pop and catch, is what we call it, for the solar arrays, where we actually release the mechanisms that hold the spacecraft in, make sure they're going to work flawlessly when we get up on orbit, then move to a rotation fixture to continue processing. A lot of the processing that we really did here at the Cape was centered around making sure that we got the blankets on, that the spacecraft was cleaned appropriately, and that everything was still functioning after we moved it on the 20th of May. The blankets closeouts went extremely well. The team is, at this point in time, has them all closed out because we're on top of the rocket. And then we had to put the arrays back on. So with the arrays going on for the final time, that was the last time that we were able to see several of those bays. So a lot of that time goes into us being very careful about making sure that those things that need to stay here with us are staying here with us, and that everything that has to go with the spacecraft is going with the spacecraft. Once we were able to confirm that all of that had happened, we were closed up inside of the fairing. And as Tim showed, we moved out to be stacked on top of the rocket. It's certainly been an extremely exciting time for everybody here. Things have gone exceptionally well. Our partners have been very supportive and couldn't be happier with how well things have gone to this point. So, back to you, George.
Thank you, Rich. And now for the weather on Thursday. Clay Flynn is the launch weather officer during the countdown. You'll be hearing from the 45th Weather Squadron at Cape Canaveral Air Force Station. Clay?
Thank you very much, George. If I could have the satellite picture up, I'd appreciate it. If you look down in South Florida, you'll know we have quite a bit of cloudy conditions, some showers and isolated thunderstorms down south. That's associated with the surface trough that pushed through our area yesterday. You may recall yesterday we had a few showers over the area. It did push south. It should remain south through the next several days. It does become a little more broad and diffuse as it starts to lose its characteristics into this weekend. But for the most part, the boundary should remain to our south. Over central Florida, we have high pressure building in, clockwise flow around high pressure systems, so we would expect to have easterly winds blowing from east to the west, not only at the low levels, but also in the mid levels of the atmosphere. When those conditions exist, afternoon and evening thunderstorms favor the interior of the state. So really, what we'd expect to see for the pre-launch operations tomorrow, for the most part during the day, and for the launch count on Thursday, we'd expect the sea breeze to set up mid to late morning. By early afternoon, we should see it over the mainland or nearing the mainland. As the sea breeze sets up, we'll see a small thread of an isolated shower. I don't think we'll see thunderstorms at that time of day, but should see showers starting to develop along the sea breeze and migrating to the west. So once we pick up the count, we'd expect to see a band of clouds to our west with showers, with additional late afternoon heating showers and thunderstorms developing on that sea breeze. But again, the sea breeze should be to the west and migrating to the west. As we near sunset, oftentimes we'll start to favor clouds coming in off the water. So we'd expect to see some cumulus clouds coming in off the Atlantic, and that again is our principal concern for the attempt on Thursday night. So if I could have the forecast brought up, please. What we'd really be looking at is a scattered deck of clouds at about 3,000 feet, another scattered deck of high clouds at about 26,000 feet. Good visibility, should be about 7 statute miles or greater. Our winds out of the east-northeast about 0.70 gusting to 15 knots, well below the liftoff constraints, with a 20% chance of violation for the first attempt on Thursday evening. And the principal concern there would be cumulus clouds, and again, that would be with the deep easterly flow, clouds coming in off the water, moving from the east to the west. So that's the principal concern. So looks pretty favorable for the first attempt Thursday evening. If I can move on to the 24-hour delay, should we be on the pad? Similar conditions for Friday evening. Should we have a 24-hour delay, with the exception that we do have a few little perturbations in the flow that should enhance the cumulus clouds over the Atlantic, and possibly an additional shower or two coming in off the Atlantic, and we do start to moisten up a bit on Friday and Saturday. So a little greater threat of a cumulus cloud rule violation, a lesser concern for any type of anvil cloud, but nevertheless there was some anvil cloud that could possibly form from thunderstorms up to the north with a little upper level disturbance. So what we look for on Friday then would just be scattered low clouds. Another broken deck now at about 24,000 feet, good visibility. Our winds a little more easterly, still gusting in the mid-teens, well below the constraints. And as I mentioned, a 30% chance of violation. If I could have the 48-hour delay, she would be on the pad. And pretty much a carbon copy on Saturday. If we're on the pad, similar conditions, cumulus cloud and a lesser threat of an anvil cloud with a 30% chance of violation. Wind still well below the constraints coming off the water with gusts about 15 knots as we near sunset. That's all I have, George. Thank you.
All right, thank you, Clay. And we're ready now to take questions. We'll start first here in the room with questions. Then we'll take some questions from the phone, and then we'll go to our social media, which you can ask questions on social media by hashtag AskNASA would be where you go to ask a question. So let's start here in the room first. Ken?
Hi, thank you, and good luck, first of all. Ken Kramer, Universe Today and Northeast Astronomy Forum. My question is for Dante. So we know that comets and asteroids brought a lot of water. Your mission is about organic molecules. Can you tell us what we know or don't know about the organic molecules that were brought early to the early Earth by these asteroids? Whether they survived, were they pulverized? Could they possibly have contributed at all to the original life here? Thanks.
Absolutely. One of the leading theories for the delivery of organic molecules to the surface of the Earth after that late heavy bombardment period is the exogenous delivery, or the delivery from asteroids and comets. And we do have rare classes of meteorites that we call carbonaceous chondrites where we see some of these organic molecules, and that's really what has made that hypothesis viable. But a lot of our analyses are confused by the fact that meteorites, once they're on the surface of the Earth, are very quickly contaminated, organically especially, because microbes love these materials. They get in there, they colonize them, and the things we're looking for are the things that these bacteria are made out of, the amino acids that make up their proteins, particularly interested in the handedness. You know, some organic molecules have a right-hand version and a left-hand version, and life preferentially chooses one over the other. So we're really interested in what were those original inventory of materials, the seeds of life that these carbon-rich asteroids and comets may have brought to the surface.
Right here.
Jim Siegel, I'm with the Celebration Independent and Spaceflight Insider. I'm interested to learn a little bit more about the asteroid itself, Bennu. For example, why was that particular asteroid chosen? How far is it from Earth? How far will it be at the time that this landing occurs? From the video, it seemed to be in a roughly same orbit as the Earth, and I wondered whether that was true or whether it's just kind of passing through. A little bit more about its history. Thank you.
Well, I'll take that one. So when we first started selecting the target for OSIRIS-REx, we levied some engineering constraints on the system. We were working with Lockheed Martin. We were going to use their heritage design to the greatest extent possible to minimize development risk. And we made a couple key decisions. One of the big one was no radioisotope power source. We were going to go with a solar array for our power source. And we didn't want to have to go too far out into the solar system so that we could maneuver around the asteroid and still have plenty of power for our instruments. That limited us to objects that didn't go out 1.6 astronomical units, remembering that 1 astronomical unit is the average distance between the Earth and the Sun. We also didn't want to have to deal with major thermal control systems. So we wanted to stay away from the Sun as much as possible, and we set that limit to 0.8 astronomical units. We also made the decision to fly the Stardust sample return capsule design, and that was rated to a re-entry velocity of 12.4 kilometers per second. And that criteria set a constraint on the inclination of the asteroid's orbit relative to the Earth, which is the angle of the asteroid's orbit relative to the Earth's orbit. That had to be less than 10 degrees. So but just those 3 constraints got us down to near-Earth asteroids in very Earth-like orbits. And then we wanted to pick an asteroid that we felt would have a significant probability of the loose regolith on the surface, because we're going to go with this tag sample acquisition concept of gas stimulation. And so we needed something that was relatively large, because when asteroids get to be about 200 meters or in diameter or smaller, they tend to rotate very rapidly, sometimes as often as once every minute, and that would likely fling any of that gravel off the surface. So we went to something about 500 meters when we chose asteroid Bennu. After we went through all of those constraints, we were down to about 24 objects. And finally, science got to come in and have a vote, and we wanted that carbon-rich composition to help with our investigation of the origins of life in the solar system. And there was 5 asteroids that met all of those criteria. We selected asteroid Bennu as the final target of OSIRIS-REx because it was so well characterized with radar data, telescopic data, that we felt that really reduced risk to the mission profile.
Earth?
So its orbit, it varies. It does a close approach to the Earth once every 6 years. It's in an orbital period of 1.2 years. Earth goes around every 1 year, so every 6 years they line up. And when it was discovered, it was about 3 times the distance that the moon is from the Earth. But on occasion, it gets on the other side of the sun, so it can be over 2 astronomical units away. And it's that phasing that changes every 6 years. There's a close encounter between the Earth and the asteroid, and then they go apart and they come back together.
Okay, let's come over here to Stephen.
Thanks. Stephen Clark from Spaceflight Now. I have a couple of questions. First, maybe for Dante, and if anyone else wants to chime in. I'm curious, interested in how, in your nervousness and anxiety going into the launch, would you consider this the riskiest part of the mission? You have a lot of things that seem pretty untried to come. I was interested in how you're feeling now compares to some of the risks that come on once you get to the asteroid, and I have a follow-up.
I'm absolutely not nervous because we have a phenomenal team and they know what they're doing, and I have my full trust and faith in that they're going to get this job done. I am anxious because I've been working on this program for 12 years now, and I really want to fly this spacecraft that Lockheed Martin has built for us. But those are 2 very different states of mind. I want to make sure you understand how much faith I have in this crew. It's an awesome experience of a lifetime for me to be here and work side by side with this team and see how professional and thorough and dedicated they are as we go. And a hallmark of OSIRIS-REx has been effective risk management. There's risk in this business, we all know that, but we really set out to actively identify, manage, and mitigate our risks. So absolutely, we're going to fly a spacecraft into the surface of an asteroid and get a sample, and we're going to drop a return capsule at 27,000 miles into the top of per hour into the top of our atmosphere and recover that material. But we understand the risks, and as we've gone through the development program, we've had the resources, and it's really a testament to being in the New Frontiers program at NASA that we have the resources to manage this program properly. And I am very confident that we've managed the risks and we understand them, and that this mission is going to succeed. And probably Mike and Rich want to follow in on some of that.
I sleep just fine.
I know this mission is coming in a little bit under budget, so maybe Jeff and Dante can tag team this one. What happens to that money that was saved during the development, and is it to stay within the project, and what sort of augmentations might you be studying to use that funding in the future?
So within the Science Mission Directorate, we manage our missions as a portfolio. As I mentioned earlier, we have over 114 active missions going on. So there are some missions that may come in a little bit above, some missions that come in underneath. So we manage, again, at the portfolio level, not just at a single mission. And so as we go through and look to make sure our the science, or what we call our Phase E, is well funded to make sure we achieve the great science, we also look at what funds are needed for other missions that may be a little bit more in trouble. So again, we do a portfolio management, not just a single project management.
Okay, Daryl, do you have a question? Right here.
Daryl Nail, Fox 35. Was there any debris, this is for NASA and ULA, was there any debris found from the anomaly over at 40? And if so, what was found, how much was found, what was the impact?
I'll let you take that.
Okay. Yeah, so what I can tell you is that our teams did an extensive walk down of the pad area and the VIF, and our Atlas V vehicle as well as OSIRIS-REx are safely buttoned up and secure inside the VIF. We haven't identified any damage or any concerns as a result of the incident last week. And we do continue to evaluate our progress as we move towards launch. But at this point, we haven't identified any risks, and we're on track for launch on the 8th. Was anything found? Not that I'm aware of.
All right, we're going to go to the phones now. Bill Harwood, I think you're on the line.
Yeah, thanks a lot, George. Just a quick question for Dante. Actually, 3 quick questions, but I promise they're quick. Looking at the flyby, I was wondering what the distance is at close approach. Did you plan any earth obs during the flyby, either for science or to test your instruments? And finally, is this strictly plane change, or is there some velocity component plus or minus? Thanks.
Sure. So 1 year after OSIRIS-REx launches from the Earth, we'll come back to the Earth and do an Earth gravity assist. And that is primarily for the inclination plane change to get us onto the 6-degree inclined plane that Bennu orbits on. The distance of close approach will vary depending on exactly when in the launch window we go. Roughly about 20,000 kilometers will be the range. But again, that's variable depending on the specifics of our launch injection trajectory. It is a great opportunity for us to check out our whole instrument suite. NASA missions in the past have learned an enormous amount about their spacecraft and, more importantly, the ground system and the team on the ground and how they deal with all the payloads, all the requests from the science teams, and then downlinking and processing of the data. So we have a fantastic calibration and observation campaign, both of the Earth and the Moon. We'll be doing some things like checking out instrument alignments. You know, we've aligned these things very precisely relative to each other, but you might expect some small shifts from the launch environment, and the Earth and Moon observations will allow us to test that. We'll also go through some of the con-ops for the Bennu encounter, like one of our stations called Detailed Survey, where we have to slew the spacecraft north and south in order to cover the entire surface of Bennu. We'll rehearse that. And we'll also get some really great data on our homeworld and on the Moon using our spectrometers and our cameras. So it's a great opportunity for us to check out the team, check out the spacecraft, and also look at our home.
All right, Irene Klotz on the phone.
Thanks, George. I have a question for Tim and or Scott. Have you received any information from SpaceX that gives you the confidence that there's not a generic rocket equipment issue that could also affect the Atlas V and or a ground support equipment issue? And if you have gotten any information that gives you that assurance, what have you been told?
So I'll take that one. First of all, our hearts do go out to our colleagues over at SpaceX. If you've been in this business long enough, you've experienced a day like last Thursday. It's nothing that any of us ever want to see. However, it is part of our business that has very harsh consequences. SpaceX, very resilient company. We were fortunate to launch with them earlier this year, the Jason 3 mission out at Vandenberg. So have a little bit of experience knowing their culture and look forward to their return soon. So with that said, given LSP's position, having spacecraft on both ULA's line of products, Atlas V, Delta II, and Delta IV, and also on SpaceX's Falcon 9, we are in a special position where we're able to look at very closely held launch vehicle data, the proprietary data for both. So our team, led by our chief engineer for LSP, led a crossover assessment of launch vehicle hardware from what we were able to observe and know from the data from the event on Thursday for Falcon 9, and compare that against the systems of Atlas V. And that assessment did complete over the weekend, and our chief engineer was able to report in that the review was complete and that there is no elevated risk to OSIRIS-REx launching on an Atlas V.
Okay, we're going to take a couple of social media questions here.
Okay. This first one is from at CrowTRobot, and it's for ULA. It's, will the Centaur stage be deorbited after release of OSIRIS-REx, or does it go into a, quote, disposal orbit?
No, since this is a trajectory that takes us out into the atmosphere, it just continues on out there.
And then we have a question for mostly for Dante Loretta. He wants to know, this is at Bealgram, what do you think Mike Drake would have to say today?
Well, at the end of our launch readiness review, we had the opportunity to remember some individuals that we've lost along the way. And Mike Drake was my friend, my mentor, and the visionary who brought me onto the program in 2004 as his deputy principal investigator. And together, he and I worked for 7 years along with our partners at Goddard Space Flight Center and Lockheed Martin to bid this proposal to NASA multiple times until we were ready for selection as the third New Frontiers mission. So we miss him dearly. He passed away in September of 2011, 4 months after we were awarded the contract to begin the mission OSIRIS-REx. I know he's still with us. He's in our hearts, in our souls, and he's looking down on us, and he'd be really proud today. And he'd be having the time of his life as well.
We have a question from at Fossil Locator. This is probably mostly for Dante. Specifically, what type of carbonaceous asteroid is Bennu in meteorite terms? We'd also like, a few other people have asked about how does this compare to meteorites that they find here on Earth?
Well, we're going out into the unknown, and Bennu is an unexplored world. We've done the best job we can with our ground-based telescopes and our space-based telescopes to try to infer its composition. We do know it's very dark. It has an albedo, which is its reflectivity of only 4%, which means 4% of the sunlight is reflected back into space and 96% is absorbed. The problem with these carbonaceous asteroids is their spectra are pretty featureless, and so it's hard to identify them exactly. And we can't link Bennu to a specific meteorite class, and in fact, that's one of our science objectives, is to do that and understand what meteorite it may be linked to. Our best estimates are that it's related possibly to the CI or CM carbonaceous chondrites for the uber meteorite geeks out there. But we don't know, and we're going to explore this world, and we're going to bring back a sample, and then I'll be able to answer the question definitively.
And one final social media question before we come back here.
And this is pretty much for the whole panel. At Mike Sianda wants to know, what aspect of the OSIRIS-REx mission are you most looking forward to?
Take one answer on that. Who would like to take that?
We'll let Rich answer that one.
I think that the thing that, one, I'm most appreciative of, and then two, that I'm looking forward to the most. I'm most appreciative of all the people that have had a chance to work on the mission and get us to today. So it's been an amazing journey. I know that at our peak, just us alone, we had 900 different people touching the satellite in a given month, and that's pretty impressive. So it took a lot to get here. And in terms of what I'm looking forward to the most, I think it's developing that understanding of what we don't know, bringing back a sample. Dante actually probably brought it up, and it's something that stuck with me. The fact that we're going to have sample material here on Earth that we can experiment on with techniques, with people, with instrumentation that nobody's even thought of yet in the future is something that's phenomenal, and it's something that's unique to sample return missions, and so that's what I'm looking forward to the most.
Right, we'll take two more questions right here. Marcia Dunn.
Marcia Dunn, Associated Press, both for Dr. Loretta. Realizing you're calm today, I'm just wondering, when you saw that SpaceX explosion last week, did your nerves jangle just a little? And secondly, was there any thought ever given to actually landing on the asteroid as opposed to just scooping up and get going pretty quick?
Well, I think, as Tim said, you know, nobody likes to see your colleagues go through a day like they went on Thursday. So sure, I mean, it was a stark reminder to me and to this whole team about the risks that we face in this business. And in many ways, you know, it made us take a look again at everything we had done, all of our processes, all of our procedures, all of our equipment, And as I've said, this team is awesome, and it's an honor to be able to watch them work. You know, as the principal investigator, I don't have a role in building or launching the rocket. I get to kind of enjoy the ride and observe the team, and it's something I've dreamed about since I was a little kid, to be able to climb around on the vertical integration facility and see a rocket getting stacked that's got my spacecraft on top of it that we're about to send off to an asteroid. Sometimes I have to just pinch myself to convince myself that I'm not dreaming all of this, that it's actually happening, and that I have the honor and the privilege of leading this for NASA and for the nation. What was the second part of your question?
What would be the pros and cons, even if that were possible?
Early on in the mission design, the OSIRIS-REx team looked at the options of landing on the asteroid and doing extended surface operations versus the touch-and-go maneuver. And we quickly came to the realization that there's just so much unknown about the surface of the asteroid that the idea that you could develop a harpoon or an anchoring system or use hold-down thrusters to keep you on the surface was deemed to be too high a risk for the program. And in fact, the way to go was the short duration touch-and-go contact using the pogo mechanism to reverse the momentum of the spacecraft and send it on a journey away. And I say, as we watched our European colleagues drop the Philae lander onto the surface of Comet 67P, they intended to land, but they bounced. And I looked at that and I said, all right, that's what we're planning on doing. It just shows me that that was the right design solution.
James?
James, Dean Florida today. Question to follow up. Dante, maybe a good segue. I was just wondering if you could talk a little bit more about the moment of contact. Obviously, your anticipation of that event some years away, but what will you see and what will we see?
Yeah, the OSIRIS-REx team has identified the TAG event not only as the culmination of the mission, right? That's what we're going to spend a year and a half mapping the asteroid to select the right location to get that device down to the surface and collect that sample. But we're going to learn a lot about asteroid surfaces just from that event. And so we've already laid out our whole TAG reconstruction process. So after the event takes place and we've got that key decision to make, do we have sample? Are we ready to stow in the return capsule? Or are we going to use some of our reserve gas bottles and go back for a second sampling attempt? So we're going to be getting photo documentation of the event. Our SAMCAM primary job is to watch the TAG SAM interact with the surface of the asteroid. We've also got the nav cams, which are wider angle cameras, and they're going to be able to see some of what's happening as we interact with the asteroid surface. And we're going to be looking at spacecraft telemetry. We've got the inertial measurement units, which will be telling us about all the forces that are acting on the spacecraft, and through our knowledge of the spacecraft subsystems, isolating those forces that are the result of the TAG SAM, the asteroid regolith interacting with the TAG SAM device itself. So one of my co-investigators on the science team, it's his job to go through that data within 7 days and prepare a TAG reconstruction report to describe how did the asteroid surface respond to the TAG event. That's going to complement the TAG reconstruction report that the spacecraft team at Lockheed Martin and Goddard Space Flight Center are going to put together and say this is how the spacecraft responded to the event. And we're going to take that into our sample success review to decide if we've got enough material to come home. But we're also going to do a long-term analysis of that to constrain the properties of the asteroid surface and the regolith grains.
Okay, we've got time for one question over here. Let's go right here.
Hi, Don Haladiak, CBC. I think for Rich Coons, can you explain a little more detail how the TAG SAM, the touch-and-go sampler, works? I understand there's nitrogen gas going to kick up a plume, but how does it get directed into the sampler?
So it's really a reverse vacuum. So if you think about the video that we showed, right, we've got the compressed gas, and as we come down, we'll actually detect that contact and that pogo will start compressing. When we detect that, we'll release the gas, and what that'll do is that actually gets all the material moving, right? And then since space is a vacuum and we've now released gas into it, that material is going to want to go on the path that we've set for it, and it'll ultimately be collected inside the TAG SAM head, because that gas will move up and then go through the side of that air filter.
All right, with that, we're going to wrap up. We have a science briefing following this one, but we're going to divide our programming because we have an on-orbit event on the space station we'll be covering on the NASA Public Channel, on the main channel. That will be at 2 o'clock. And then in parallel on the NASA Media Channel will be our science briefing. And we will replay the science briefing at 3:30 on the main channel, on the public channel. And then looking ahead to tomorrow, we have two briefings. Our customary social media briefing will be on NASA television starting at noon. And then at 1 o'clock, also on NASA TV, will be a joint social media, news media briefing on uncovering the secrets of asteroids. Our programming on launch day will start at 4:30 with status and live audio from the launch conductor as they get into the countdown and prepare the Atlas V for fueling. And then the launch commentary with our interviews and discussions of all the events to come will start at 5:30. So with that, that will conclude the pre-launch news conference. Thank you very much.